Welcome back to our lecture on Java. Today we are going to look at string class, and these are the contents of the topics, or you can say the topics we are going to look at under this string class. And we want to start first by looking at the design. But before that, we have to mention that string class is one of the most important classes in Java, because the main method requires it for it to be a legitimate main method or an entry method for a Java application. This essentially means that without the string class, you will not be able to run your application or to kickstart it. Then string class is immutable. So by immutability, we mean that the state of the object will not change once it's created. And to make the string class or any string or any class in Java immutable, the class must be final, declared final to prevent extension, because anyone who can extend your class can exploit it or be able to add additional behavior to it or do anything he could possibly want to do with it. The fields of that class must be final and private, and it must be instantiated or initialized through the constructor, and the class must have only the getter methods, and the getter methods must return the copy of the field or the copy of this object. That's it with regard to immutability. Another important thing we see with string is that to create a string object, you don't require a new keyword as you would with other classes. Just saying string str equals to Java, under the hood an object will be created for you. It will be stored because this is a string literal in the constant pool, and this is just a synthetic sugar, and this str is an object. And we see that this is similar to what we saw with Repo classes. You can just say integer I equals to any number you want, or you can say character C equals to whatever you want to put there that is a legitimate or appropriate type. Then the string methods. These are one of the most used string methods within the string class that you will normally have to be able to use. And you can just look at the Java docs to see how to use all of them in your Java source code. Then we have what we call the string constant pool. Before defining the string constant pool, it's important to explain what's a constant. So in any language, a constant means that a variable or a field cannot be reassigned once it has been assigned. That's the whole thing. This is you can almost confuse this to immutability, but with immutability we are saying the state cannot change. So the string maintains an area of storage called the string constant pool in the heap. The string constant pool is sometimes called intern pool. And pooling is the process of ensuring that only one copy of each string literal is stored in the heap. And this is sometimes called interning. So the literal strings and compile time string valued constant expressions are automatically interned. So on the left we see compile time valued constant expression, and on the right we see non-compile time. So I will just demonstrate this in code. If we have string if we have string bd equals to bd, and we have string c equals to b plus d, bd equals to c. If we run this code, the expression we get true, because what happens is that this bd will automatically be interned, will be saved in the constant pool. Then the evaluation of these string literals will also be interned. So one of the things that happens with automatic interning or explicit interning is that what you are essentially doing is you want to check whether the literal or the object, the same thing already exists in the pool. If it's there, you return the object that already exists. You don't create a new one. So since in this line 7 this was interned, the evaluation of this, it will compile, or the runtime will try to intern it and find that it's already there. Then it will return the same object. So essentially we can conclude that what C variable is pointing to in memory is what BD is pointing to, because this is reference comparison. So reference comparison, you want to check if two variables are pointing to the same object in memory. Then you can also have a compile time constant in this manner. So you have B, and then you have B here, you have string D, then you have string, you can just call it A, you can say B plus D. And let's see what happens if we compare BD to A. This should give us false. Why? Because this will not be intended, because you're not having an expression that involves literal. It involves variables, and these variables are not compile time constants. But if you want to make them compile time constants in a way that interning can happen, you can hint the compiler by mentioning that this are final. Then if you have it like this, then it will be true when you run it. As you can see in this code, it's final. So in a way, when we remove the final keyword, we are already talking about non-compile time constant. As we can see, even if maybe we say b.intern here, this will not solve our problem, because already these are just two different things. We have this, but if we want to make the interning work for us, what we need to do now is we need to add expression and say intern. In this way, you are saying the result of that will be intern, and we see that these are not compile time constant, so that doesn't matter because of the intern method you have applied. So this should give us true. You don't need to put final there. So that's it with regard to the interning. So we have mentioned that all literal strings, compile time, string valid constant expressions are automatically interned. We have seen how the interning works. We have explained that. We don't need to explain anything here. Okay, we have mentioned, okay, you can also decide to do intern as we did. So when intern method is invoked, according to Java docs, if the pool already contains a string equal to this string object as determined by the equals method, then the string from the pool is returned. Otherwise, the string object is added to the pool, and a reference to the string object is returned. So it follows now then that for any two strings, s and t, s.intern is equals to t.intern is true even only if s.equals t is actually true. Then we have other strings in Java which are actually complementing the already existing string class. We know that string class is immutable. So these other strings, you can think of them as mutable versions of the string class. That gives you more functionality to perform on the string object. All they do, they give you more complex string manipulation features to perform. But these other strings are different in the way they are implemented. What we see is that the StringBuffer is thread safe. And what that means is that if you are using it with different threads, once a thread uses or calls one of the method inside that object, the other thread cannot be able to call that because a log will be acquired on that object so that no other threads can change the state. If you can look at the StringBuffer, let me just say StringBuffer, you will notice that all the methods are synchronized, and the class is final. So a synchronized method essentially means that if two threads are trying to call this method simultaneously, they will not. The first thread that entered here will prevent the other thread from entering. That's about synchronization. So you want to have data that is reliable. So this is not a thread lecture. Threading has a lot of side problem or side effects that we will look at when we are dealing with threads, things like race conditions, live locks, and deadlocks, and many others. So we see that the methods are synchronized. Let's look at the StringBuilder. The StringBuilder, the methods are not synchronized. And another thing that we see that is similar to all these classes is that they both extend abstract StringBuilder. You can look at abstract StringBuilder. They both extend and they are comparable and implement this. So essentially they are special types of strings. So with synchronization, obviously you have low performance because of that waiting period each thread has to wait. But with StringBuilder, you have high performance because they're not synchronized, but now you lose thread safety. And so now you have to make a choice when you are in a situation where you don't really care about performance, but you care about the consistency of data, of the state of your string. You will go for StringBuffer because you will have thread safety. If you are in a multi-threaded environment and you don't really care about thread safety and you want speed, you can go for StringBuilder. So then there's another thing in string called StringTokenization. So StringTokenizer is the process of breaking a string into pieces. Java provides different classes and methods to help achieve this. The StringTokenizer class can be used in the split method of the string. The StringTokenizer can be passed a delimiter and the split method can be passed a regular expression to determine how the string should be broken. So this is a mistake on the slide. StringTokenizer does not accept a regular expression, but the split method does. Then we can see and use both of this and see just in a short period. So if you have string str equals to maybe a long Java, then you want to tokenize this string tokenize st equals to new string tokenize str, delimiter, you say it's a space. Then this essentially means that you are tokenizing the string based on space. So when it sees a space, it whatever that comes after space is the next token. So if you run this code, it must give you I love Java separated in lines like that. I love Java, as you see, like this. You can put anything that you want to put here. If you do not put anything, the whole string will be returned because there is no delimiter as one token. Then you can use the split function to tokenize this string. So, but the split function returns an array. You can just call s equals to str.split. So we can use this as our regular expression. And then what we can do here, we can do x in s. And what we can just print here is x. So you'll definitely get the same results you get previously. Or if you are using a regular expression, let's say here you have digits. You can now provide a regular expression to say anything that is not a character. You want it to be a delimiter. So that means this would be your delimiter. Let's run it and see. You see that we have a space here. It's because here we have two digits that are coming that are consecutive. So to tell Java that if they are consecutive, treat them as one delimiter. You can add a plus sign here. Then you run it, you should get the same behavior. But this is not a lecture on regular expressions. You can read more about regular expressions on your spare time and see how you can apply them in your code. And then we have the string format, which is the reason I added this in this lecture is because I've noticed that it's mostly used in the application. One of our application that we were writing in one of our clients, we heavily used this format method in the string class to format a string. This method receives placeholders and arguments, and internally it uses the formatter class. And placeholders, you can provide different kinds of placeholders. Let's just see what this will do for us, and we will look at the, let's say we have a string like my name is, we put a placeholder, and my surname. Okay, we can just say my age for now, and we can just delete everything here. Sorry. So you can say str.format, or you can just say string format str, then you give the name. Let's just say name, you say Java. So you see that where you put this placeholder, it puts Java. Let's say you put another placeholder here and you run the application. It means now that you have two placeholders. That means you must have two parameters. So age, maybe you can say 20. Now it should work. There are cases whereby your placeholders, you can want them to be of certain types. Now comes the use of placeholders. Let's look at how this formatter class is actually defined in terms of those types of placeholders. You see that there's you can have an S as an argument, and then that would give you a general type. And if you make it a capital S, it would be a string. You see that obtained by invoking a toString, and it would be a capitalized, so the string would be in uppercase. Then if it's H, it's to hex string. Then you can have others like let's say maybe you want it to be a decimal number. So what you can do here, instead of putting an S, because age obviously is a number, you can put a D here. So if we run this, okay, it's because now this is a digit but you passed a string. So let's pass a number, then this works. So this has those conversions that needs to be done for you, and you must be careful when you're using this, because you will get illegal argument exception or those type exceptions if the type is not the same as what you are working with. So other than that, you can do theta reading on the formatter. It has other placeholders that you can apply. Dates, you can have a whole lot of placeholders. You can do theta research on that.